Alright, here we have a problem in which a pitcher throws a ball at a batter, and the ball will do something like this. Something like that, maybe not that low, but it will fall a little bit, right? And we want to figure out how much it's going to fall. So let's say we know the initial velocity of the ball here. And let's say we know how far apart they are. D. And I want to find how far down this thing is going to fall. Okay, so this is a projectile motion problem, or a two-dimensional kinematics problem, you might call it. Well, I know that because I've got velocities, distances, time, probably, maybe some acceleration. That sounds like kinematics, and clearly it's moving in two dimensions, right? It is going to be moving, obviously, here in what I'll call the x direction, sideways, but it's also going to move downward in the negative y direction, which will be down. Okay, so if I suspect it's kinematics, I might as well just get started. I know I'm going to have to list out the knowns and unknowns, and in kinematics we have x, x initial, vx, vx initial, acceleration, the x direction, t, and then I have all of those for the y direction as well. And of course time is the same in both dimensions. It doesn't actually split apart and go anywhere. It's going to be at the same time that the ball arrives. And remember, the interesting thing about two-dimensional kinematics is we can actually break the velocity vector up, or whatever vector we want, up into its components, do kinematics on the components, and we will actually get a real answer. Alright, so let's fill these in. We've got this v initial. Well, that is all horizontal, as I've drawn it here, right? He threw the ball straight ahead of him. So the v initial is actually vx initial, right? So that's v initial there that I've labeled. We have a distance, so that appears to be some sort of a change in x, right? That's in the x direction. So let's say it starts at a position of 0, and it ends at a position of D. Okay, now we have got, what else have we got? Well, we can decide if we want to that it started, say, at 0y, right? Maybe that's not the choice everybody would make, but I did put my origin right at the ball, right? So it's starting at a position of 0, 0 right there, right? So that's why I have x initial equals 0 and y initial equals 0. Alright, and as you can see, that probably means my final answer for the distance it's fallen is going to be negative, because it ends up below the x-axis down here in negative y territory, but that's okay. But also, that kind of gives me a hint. That means, look, I'm looking for this line, the height of this line, which will be my y final. Right? So that is actually what I'm interested in finding. How far down it falls, as in how far away from the origin is it in the y direction. Okay, let's see, do we know anything else here? How about the accelerations? Well, we're probably on Earth, right? I didn't say anything otherwise. So the acceleration in the y direction should be negative g. Right, because I said up is the positive direction. Acceleration due to gravity, of course, points down, which in this case is in the negative direction, so it's got to be negative g. All right, and ax, well, I mean, the ball was thrown, and it was given velocity, but after that, unless the ball has some sort of rocket engines or something, it's not going to continue accelerating as it flies through the air, say here or here. It's just flying through the air. So the acceleration in the x direction is actually 0. All right. The velocity in the initial velocity in the y direction is going to be 0, right? It has velocity in the x direction, but right after you throw it, it's not falling, it's not moving in the y direction, it's not raising up or falling down, not right after you throw it. And so initially, the velocity in the y direction is 0. I don't know y, I don't know vy, and I don't know t. Those are 3 unknowns. I'm not going to be able to solve, I'm not going to be able to use kinematics to solve this. Remember, I generally need to know everything but 2 things, and then I can use kinematics. So it looks like I can't get my answer right away. But remember, the time is the same in the x and y direction. So if I could solve for time in, say, the x direction, I could plug it into the y direction and get my answer. Okay, so let's see if we can do anything in x. I know x initial, I know vx initial, I know x. I'm only missing 2 things in the x direction. So I should be able to solve it. So then let's set our sights on solving for time here with the x components, and then when we're done we'll plug it in the y components and see if we can get our answer. So for x, the equation I'm probably going to want might be this one. There. Now this is probably the ugliest equation, but some stuff is going to zero out, right? Acceleration in the x direction is 0. Initial position is 0. 0. And that zeroes these terms out. And I'm looking at x equals vx initial t. I mixed it up there. Oh. So that is no surprise. Aren't we just looking at distance equals rate times time? Does anybody remember that from algebra or something? Yeah, that in fact, this equation does simplify down to that when you have no acceleration. It's basically just the definition of velocity. So time is going to be equal to x divided by vx initial. Okay, so let's put that down over here. That's x over vx initial, and indeed, right here, the time is x divided by vx initial, which are 2 things that we know. Oh, and I was actually calling this the v initial from my picture, right? Because the velocity initial was all horizontal. Okay. So then, now looking at the y equation components here, I'm only missing 2 things. So I should be able to solve for y. I think we're going to use the same equation. Let's see, with y's of course. Y initial plus vy initial t. Now let's see, we're going to go ahead and zero out vy initial and y initial. And plug in t. And now just to match the initial things given, I believe I said that x final was d, that distance, and ay is negative g. So there we go. That is apparently the distance that the ball will fall through the air before it gets to the pitcher. To the batter, sorry. We solved that knowing only that the ball was traveling horizontally a certain velocity and going to have to travel a certain distance, right? We suspected 2-dimensional kinematics, so we just went ahead and listed out all of the knowns and unknowns in kinematics form here. We wanted to solve for y right away. We weren't able to do it though. So we solved for time in the x direction, plugged it into the y numbers here, and then we were able to solve for our final answer, which is what was y final, how far it fell from the origin where it was released. Alright, that is it. I didn't make up numbers. Sorry, you can make up your own. Good luck.